morning, everyone. Let's talk about winning with AI. Because we all know that there is incredible excitement about the potential of AI and machine learning to transform the industries that we work in and that we serve. And of course, we've all seen the breathless estimates of the potential economic impact of the widespread deployment of AI and machine learning produced by the consultancies and the think tanks. One recent estimate from PwC values the potential economic contribution of AI to the global economy at $15.7 trillion. And for comparison, that's more than the current output of China and India combined. But as the old Danish saying has it, prediction is difficult, especially about the future. And even the consultancies would acknowledge that there is a wide margin of uncertainty on those estimates of the future economic value of AI. What we know for certain, though, is that the market cap of the big five technology firms increased by more than $2 trillion this year on the back of the excitement about the potential of AI and machine learning to transform society and the economy. And The Economist makes that $300 to $400 billion in increased annual revenues that the market is expecting the big five to deliver from AI and machine learning products and services. Of course, the markets have also been volatile recently, with some commentators suggesting that that reflects increased investor caution about the likely return on investments in AI and machine learning over the short term. But if we stick to what we know, we do know that AI and machine learning adoption rates are still relatively low. The US Census Bureau estimates adoption rates in the US at around 5%. Official Canadian numbers suggest 6%. Data from the UK are more optimistic, suggesting 20% adoption. But honestly, those different survey methodologies mean that directly comparing those numbers is risky at best. As a proud Brit, I'd love to think that the UK is streaking ahead of the US in AI and machine learning adoption, but somehow I rather doubt that's the case. What we do also know for certain, though, is that a very high proportion of AI and machine learning projects fail. In fact, according to one recent study from the Rand Corporation, 80% of AI projects fail. And that is a very sobering statistic for many of us sat in this room, embarking on AI and ML projects of our own and under pressure and scrutiny from our boards and our executives to deliver meaningful improvements in business outcomes. Look around you. Take a good look. If Rand are right, and on the current trajectory, 4 out of 5 of us are going to come up short on meeting those expectations. The same Rand study identified 5 root causes at the heart of most AI and machine learning failures: miscommunication between business and data science teams, and a lack of understanding of the underlying business problem and context. Insufficient or inadequate data compromising the process of model training. What we sometimes refer to in the industry as shiny object syndrome, a desire to use the latest and greatest technology, whether it's really appropriate or not. Focusing more on the process and the infrastructure to support model training, and not giving enough consideration to questions of deployment and operationalization of AI and machine learning. And lastly, of sometimes being too ambitious for the technology, of assuming that it's a magic wand that can be used to automate away essentially any and all of the thorniest problems in our business. So in the rest of the presentation today, we're going to double-click on those root causes to discuss how we can load the dice to maximize the chances that our own AI and machine learning projects are successful. And we'll showcase projects that have successfully mitigated some of those failure modes. We'll begin by discussing the importance of an AI-ready data foundation and talk about how to create one. We'll ask if we really have to choose between tried and tested production-ready technologies that scale or newer technologies that we hope will enable us to innovate faster. We'll talk about deployment and operationalization, and then we'll touch on the magic wand discussion. How do we balance the need to be ambitious for the technology and its application with the requirement to bring downward pressure to bear on those failure rates. And finally, we'll discuss the AI and machine learning lifecycle to try and get to the bottom of this observation that miscommunications between business stakeholders and AI and machine learning practitioners are a leading cause of project failure. An AI-ready data foundation is a prerequisite to success with AI and machine learning. In fact, the RAND analysis is absolutely explicit on this point. More than half of the practitioners surveyed by RAND cited data issues as a significant contributory factor to AI and machine learning failures. So if we want to load the dice in our favor, we need to start by getting the data right. In some companies, this is partly an organizational issue. Because models are sexy and data are plumbing, in practice, we often incentivize the best talent in our organizations to pursue careers in data science rather than in data engineering. But in our experience, this is also often a data architecture issue. Because many organizations today take a one pipeline per model approach to machine learning. That means that we go all the way back to the data lake, or worse, all the way back to source systems, over and over again, to capture more or less the same data, to wrangle it to create very similar features, to train very similar models in the same and adjacent spaces. And we do that over and over and over again. And that one pipeline per process approach results in data silos and rapidly accumulated technical debt. By contrast, best practice is increasingly to curate variables with known predictive value in an enterprise feature store to enable their reuse for training and scoring other models in the same or adjacent domains. This approach is already enabling leading organizations to dramatically improve time to market for new analytics and data scientist productivity. Anecdotally, those organizations tell us that they also improve model quality that way. Because the very act of curating features for reuse encourages the team to think about whether they're building the right features. And their frequent reuse means that any issues are discovered more quickly than would otherwise have been the case, ensuring that the features have been built right too. The central promise of a feature store is reuse. Reuse of features across multiple models and reuse of features to support exploration and discovery, model training, and model scoring. But the quote on this slide tells you that the expectation in the market is that organizations will typically need to deploy multiple technologies to build an enterprise feature store that can support the entire AI and machine learning lifecycle. Many of you in this room are or were enterprise architects, and you know better than most that multiple data stores means more cost, more complexity, and what Larry Ellison used to describe as the gift that keeps on giving: more systems integration. By contrast, the Vantage secret sauce, smart scaling, advanced indexing, the industry's best cost-based optimizer, the industry's leading mixed workload management, means that Teradata customers can support feature engineering, model training, batch scoring, and near real-time inferencing, all from the same platform, all at the same time. The same platform that in many cases is already supporting most or even all of the organization's production reporting. For example, a major global airline manages customer loyalty data in Vantage, with ClearScape being used to create an enterprise feature store that enables the training and scoring of models to anticipate customer wants and needs. Crucially, Teradata's open and connected strategy enables those features to be written to open file and table formats so that multiple downstream technologies can access them, giving the airline the flexibility to use the right tool for the right job. Vantage was the clear choice to generate the thousands of features from tens of millions of observations that are used across the business daily. And in fact, when we asked the customer about their choice of Teradata, they said something that I think speaks to the value of a feature store in general, and something that speaks to the power of Teradata as a feature store platform in particular. Building our feature store enables our data scientists to focus on data science, they told us. And given that we know that 80% of data scientists still spend 80% of their time wrangling data, that's no small thing. And why would we create the feature store anywhere else? Teradata is where the data are, it performs, and it's reliable. Our next example of the power of a feature store approach is from retail finance. The bank in this example has a complex management structure, and it needs to aggregate data from multiple subsidiaries in order to meet its regulatory reporting requirements. Missing and inaccurate data can delay the production of those reports by multiple days every month, diverting subject matter experts from more valuable work and also causing significant regulatory issues. To address that problem, the bank developed a rules-based system to try and identify inaccurate data so that it could be reviewed and corrected ahead of consolidation. But the system generated so many false positives that it overwhelmed the expert resources that had to follow up on the alerts. An AI-based system running on Vantage and ClearScape has dramatically improved the process of anomaly detection, with the use of in-database feature engineering accelerating monthly processing. In addition, by combining our open source Python feature store library with a data lab approach, the organization was able to quickly and efficiently run multiple analytic experiments so that they could quickly identify the most accurate multi-model, multi-segment approach to detecting bad data in their environment and their context. Okay, let's switch gears and discuss one of the other root causes identified by RAND. AI projects that fail because the organization, I beg your pardon, is determined to use the latest and greatest technology at the expense of focusing on the business problem that we're trying to solve and irrespective of the suitability of that technology for production deployment. Now, if you're familiar with the film Skyfall, if you're a Bond fan, you'll doubtless recall that during a frosty first meeting, Q tells Bond that age is no guarantee of efficiency, and that Bond retorts, yes, and youth is no guarantee of innovation. Where AI and machine learning projects are concerned, are we really forced to choose between tried and tested technology that can meet enterprise service level agreements cost effectively, or new technologies that we hope can enable us to innovate faster? Well, our answer and the logic of our open and connected strategy is a resounding no. Yes, ClearScape Analytics delivers highly optimized in-engine analytic functions that support the entire end-to-end AI and machine learning lifecycle. But we give equal billing to R and Python as well as SQL. We work really hard on our integrations with the leading AI and ML workbench providers like Azure ML, SageMaker, Vertex, Dataiku, DataRobot, H2O, and SAS. And crucially, we continue to invest in our bring your own analytics and our bring your own model capabilities. For us, bring your own analytics is about enabling our customers to leverage open source libraries with Teradata, both in database and adjacent to the database with our open analytics framework. And bring your own model is about enabling our customers to score models on Teradata regardless of where they were trained and with which technology. Our open and connected strategy is a best of both worlds approach. You get the power, the performance, and the scalability of Teradata with language, library, and tool of choice flexibility. Let me give you an example of what that looks like in practice. The complex industrial pumps that move oil through major pipelines are safety-critical systems. So avoiding unplanned maintenance outages is crucial. And as the manufacturers increasingly move to OpEx-based business models, it's also vital to the top line too. This particular company's technology provider had trained an accurate predictive model based on an LSTM recurrent neural network, deep learning technology, and running on a Spark and Python-based technology stack. Now, as many of you in this audience will know, LSTM stands for long short-term memory, and it's a type of recurrent neural network that can be extremely accurate for classification problems. However, this particular solution scaled and performed poorly. And I think sometimes when we talk about scale and performance, it can sound a little bit abstract, like a techie talking speeds and feeds. So let's remind ourselves that scale and performance are absolutely business issues. In this case, the business issue was that the organization couldn't move to an hourly update schedule for predictions and couldn't scale the solution couldn't scale it out to predict failures for all of the pumps in the estate that it manages. And predicting failures for only part of the estate and too late to be able to take appropriate preventative measures, those are very definitely business issues. By converting the Spark-based feature engineering pipelines to SQL, we were able to load and process complex historical sensor data 6 times faster. And by training and scoring multiple per-segment failure models using Keras and TensorFlow, we were able to parallelize the model training and the model scoring process. In fact, scoring on a very modestly sized Vantage platform runs approximately 10x faster than the original solution, and scales out gracefully and linearly so that cost-effective predictions can be made for the whole estate. And accurate predictions for all pumps available much more quickly means more uptime. We've already briefly discussed Bring Your Own Model, and so I won't drain this slide. But for those of you that haven't used Bring Your Own Model yet, what it enables us to do is to import models that have been serialized using leading model export formats like PMML, Mojo, and Onyx, so that they can be scored on Teradata. Because Teradata is where the data are, because Teradata is a rock-solid, mission-critical platform, and because we can typically score those models more performantly and at much lower cost than the competition. In fact, if you join the Sicredi presentation in the AI track at this event, you will hear from the customer themselves what happened when they migrated a single predictive model, in this case for income estimation, from Databricks to Vantage and ClearScape. I won't steal their thunder. It's a great presentation and you should go. But they saw an order of magnitude improvements in performance and an order of magnitude reduction in the volumes of data that had to be shipped around the organization, and significant reductions in cost by moving a single model. Multiply those per annum savings by 10, 20, 30, 40, 50 predictive models, and that's a lot of money. And in a near future in which AI and machine learning are ubiquitous and we have millions of models deployed in production, the cost of inference really, really, really matters. And when you improve throughput and performance of model scoring by an order of magnitude, when you reduce runtimes from hours to minutes and minutes to seconds, you don't just give me bragging rights at a conference. You can fundamentally change the way you do business by repricing loans for high-risk customer segments multiple times per day, for example, or by dynamically updating credit limits. Let me give you another example of the application of that Bring Your Own Model technology. We're currently working with a large US bank to deploy pre-trained open source language models from Hugging Face directly in database. The embedding models are imported from Hugging Face using Bring Your Own Model, and they're executed in database on CPU infrastructure at scale and at speed. We'll talk some more about that in a moment. High performance in database vector distance calculations then enables scalable semantic search and retrieval augmented generation workflows. And in plain English, what that means is that email and voice interactions can be clustered to enable the identification of customer complaints, mis-selling, etc., etc. Because all of this is done on the enterprise data warehouse, the resulting signals of customer intent can be quickly and easily combined with all of the other customer and transaction data stored there. And all of this is achieved without sensitive data having to cross the corporate firewall, even as prompts. By the way, the business value of the first 3 use cases are estimated in the tens of millions of dollars per annum. Now, I anticipate that at this point in the discussion, some of you are going to be scratching your heads, wondering how this solution works and how it works on Teradata. Don't you need GPU infrastructure to score language models? Well, language models come in different shapes and sizes. There are trillion parameter large language models that can rewrite your email in the style of a Shakespeare sonnet. And there are 150 billion parameter language models for things like topic detection, entity resolution, sentiment analysis, etc., etc., etc. And the magic of Vantage means that we can parallelize the execution of those task-specific language models in database to generate vector embeddings from inbound customer communications. If you've done any stats, you can think of those vector embeddings as like principal component analysis on steroids. And what they enable us to do is to cluster the communications so that we can perform incredibly powerful similarity searches to, for example, reliably and accurately identify examples of potential compliance issues, even where the communications concerned don't include obvious keywords. Analyzing complex, multi-structured interaction data like inbound emails for rich signals of customer intent is one of the sweet spots for the current generation of Gen AI technologies. And if you want to understand more about how you can use Gen AI technologies running on Vantage to radically improve customer experience, then I highly encourage you to visit the Teradata booth at this event. Crucially, these workloads don't just run in Vantage, they run really, really, really well in Vantage. This chart summarizes some of our early customer benchmarking results. Our tests show that even a small 2-node Teradata system can match the inferencing performance of a pretty reasonable GPU. Now, these results are obviously sensitive to the size and the complexity of the model that you are scoring and the embeddings it is creating. Your mileage will vary. But if your assumption is that you need to deploy a complex to manage GPU cluster just to get started with these workloads, you should come by the Teradata booth today. Because we can show you how you can get started with Gen AI for CX right now without any additional investment. Scalable and performant inferencing of task-specific language models via BYOM in database is what internally at Teradata we sometimes refer to as Gen AI design pattern number 1. It's a really great fit for models in the 100 million to 150 million parameter range. Our Lake customers can leverage our new Bring Your Own Large Language Model capability to score more complex models on analytic compute clusters running on GPUs. That enables the scoring of more complex models, and ultimately in the near future, it will enable us to support fine-tuning too. That's design pattern number 2 on this slide. And there are times when only a trillion parameter model will do. Unlike some of our competitors though, we have no plans to train a foundation model of our own. We think that's a vanity project. Our partners have great solutions in this space, and our job at Teradata is to integrate with them so that you can use the data managed by Vantage to support prompt engineering and the development of policy layers that can guard against hallucination. And so we will shortly have an even richer set of APIs for robust integration with the foundation models provided by our CSP partners, and that's design pattern number 3 on this slide. Steve told you just now that we would meet you where you are on your data and analytics journey. And this is that principle in action. A range of options to give you the flexibility that you need to build the different solutions that your business requires. The RAND study highlights that organizations often underthink AI and machine learning deployment, that we over-rotate on the algorithms and don't think enough about operationalization. Getting that right requires us to be clear about what we mean by deployment in the first place. Using AI and machine learning to generate signals that help us to understand the business is fun and it's intellectually satisfying. But we don't create business value by simply running a model and updating a table of predictions. If we want to change the way we do business, we need to continuously push those signals into operational processes, workflows, and applications so that we can take action on them. Connecting models to workflows and applications requires us to manage how and where models are deployed. And that's why we continue to invest in our ModelOps toolset. ModelOps enables the end-to-end monitoring and management of AI and machine learning models so that Teradata customers can quickly accelerate, scale, and optimize their deployments. ModelOps can be used by all the teams in managing the model lifecycle, and it offers different user interfaces for those different personas. Put simply, ModelOps means that you can deploy more models to production more quickly. Prior to using ClearScape Analytics, the customer described in this slide had stalled in their attempts to drive business value from AI and machine learning. They struggled with the difficulty of scaling machine learning models in production. They really struggled with the challenge of governance and maintenance of the models that they had already deployed, and they had hit a plateau. They couldn't train, evaluate, and deploy more models without increasing the size of their data science team. Leveraging ClearScape was a game changer for this organization, as the numbers on this slide demonstrate. Rand suggests that one reason that AI and machine learning projects fail is because the technology is applied to problems that are too hard for the current generation of AI technologies to solve. If you were at this event last year, you'll probably remember Steve explaining that we believe that there are 3 horizons for AI and machine learning-driven strategic transformation. Horizon number 1 is the optimization of internal operations. When we are applying AI and machine learning to demand forecasting, price optimization, predictive maintenance, churn and propensity modeling, etc., we're operating in Horizon 1. Horizon 2 is about using AI and machine learning to improve products and services or to innovate and create new ones. A Gen AI chatbot to improve the mortgage application process is a great example of a Horizon 2 application. Horizon 3 is where things potentially get really, really interesting. When Unilever spoke at this event last year, for example, they imagined a near future in which bots from the retailers would dynamically and continuously negotiate range, supply, and pricing with bots from the suppliers. And in that future, the FMCG supplier with the smartest bots able to dynamically optimize selling margin against capacity, well, that supplier would potentially be able to disrupt the entire marketplace. Earlier this year, I asked a room full of EMEA CDOs to use that 3 horizons framework to classify their own AI and machine learning initiatives as being mostly about improving current operations, mostly about developing new products and services, or mostly about transforming their organization. And the results of that informal survey probably won't come as a huge surprise to you. In our experience, the most successful organizations are taking a portfolio management approach to their AI and machine learning initiatives. They are ambitious for the technology, and they do include in their portfolio at least some projects which stretch the boundaries. But they also continue to focus on use cases that, honestly, we've been talking about for decades. Churn and propensity modeling, fraud detection, predicted customer lifetime value, etc., etc., etc. In fact, I think that one of those recent economic impact studies that we referred to at the start of this presentation, this one from McKinsey, makes that case for portfolio management approach rather neatly. It suggests that the value of AI and analytics in banking alone will soon reach $1 trillion annually. But that 2/3 of that value will be delivered by what they refer to as traditional AI and analytics, regular machine learning, if you will, rather than generative AI. I think that speaks to the importance of that portfolio management approach. We are not going to deep learn everything. What matters is what works. Adopt the new technologies where they make sense and where they can add new value, whilst remembering that the best model is always, always, always the simplest model that is sufficiently accurate for your use case. Lastly, the RAND study suggests that the leading cause of AI and machine learning failures is a lack of understanding about the business problem that we're trying to solve. And to understand why business leaders and data science teams often talk past each other, we need to think about the AI and machine learning lifecycle. One of the very first attempts to document and codify the AI and machine learning lifecycle is represented on this slide. This is the so-called CRISP-DM model, the cross-industry standard for data mining to its friends. It dates back to 1996, and in fact, Teradata was one of the co-authors. One of the key insights that CRISP-DM is attempting to communicate is that the process of developing AI and machine learning models is iterative and incremental. Successful AI and machine learning projects don't start with the technology. They don't even start with the data. They start with a thorough understanding of the business problem, and they recognize and accept that the only certainty is that that understanding will change as the project unfolds. What that means in practice is that software development methodologies, even agile ones, can be a poor fit for AI and machine learning projects, especially at the start of the process. The RAND report is explicit about this, but in fact, that's not a particularly new insight, but rather one that each new generation of data scientists and their managers are forced to relearn. The practical consequence is that understanding business context is critical. Business leaders cannot afford to be hands-off about AI and machine learning projects, and successful data science teams are often embedded in the business units. Okay, I'm getting the hook, so let's bring this home. The RAND study identifies 5 failure modes for AI and machine learning projects. We can mitigate the first failure mode by starting with the end in mind and embedding data scientists in the business. We can mitigate the second failure mode by elevating the prestige of data engineering and, crucially, by deploying an enterprise feature store. To mitigate the third failure mode, we should prefer open and connected technologies that enable both and ways of working and reject those false choices between production-ready and innovative. We can mitigate the fourth failure mode by ensuring that we concentrate on operationalization at scale, and our bring your own model and model ops approaches are particularly relevant here. And we can mitigate the fifth failure mode by adopting a portfolio management approach and taking more roof shots than moon shots at the start of our AI journeys. As I hope I've explained during the course of this presentation, Teradata can help with scalable and performant Gen AI for CX on-prem and in the cloud, by operationalizing models at scale regardless of where they have been trained, by dramatically improving data scientist productivity and the time to market for new analytics with the feature store, by enabling any tool flexibility without ramping technical debt, and by offloading expensive and poorly performing Spark and Databricks workloads. So let us load the dice for you by creating an AI-ready, trusted data foundation, by enabling the detection of customer intent at scale and speed, and by running your AI and machine learning workloads better, cheaper, and faster. Thank you very much indeed for your time and attention, and enjoy the rest of the conference.